Hello everyone. In this video content, you will learn about an STL vectors in C++. I will try to give some answers for basic questions, and lastly, we will play with vectors in real examples. Vectors are provided by the STL and they are sequential container with a contiguous storage. Vectors are dynamic arrays, which means when you insert an element, its size grows automatically. But what does it mean really? It means that we can use vectors like arrays. We can access its elements directly, and more, we can resize the vector dynamically like linked lists. So we can say that in terms of use, vectors are a combination of arrays and linked lists. We can construct vectors like this. This means 10 empty area is allocated for a vec. You can check the size of a vec with a size public member function. If you want to add some extra value to this container, to this vector, you can use the pushback function. So simply this push 1 to the end of this vector, end of this container. We can create empty vector like this, for example. Here is a question: how a vector can calculate you have enough memory, sufficient memory in your computer, in your hardware. For example, you can push a lot of value there, you can push new elements. But how vector knows it, if there is enough memory or not? Actually, vector does not know if there is enough memory is available or not. Because of that, it's a good idea to allocate or push new elements in try-catch mechanism to get a bad alloc error. Right now we have enough memory, just pushing the one elements. But how we can try this the situation? How we can see this try-catch mechanism is really work? To see this behavior, to test this situation, we can use ulimit tool. If you are in the Linux environment, you can try this. So first, I will push here infinitely new elements. Like infinite for loop. So when I compile it, it will infinitely push to the elements. Right now, as you see, the binary program is not finished because it's pushing the new elements. Let's stop it. So now I will change my virtual memory sizes so we can see this effect directly. I will use ulimit tool as I said before. If you don't have this tool, you can just simply install with apt-get install ulimit. When you type ulimit -a, here in the virtual memory is unlimited. It's theoretically unlimited, right? We will change this virtual memory size right now. I'm running this example in the virtual machine, so if I break something, I don't have to care. I will not care because I can remove all virtual machine, then I will reset up, okay? Be careful about it. You can break something, okay? So also there is one important thing. You should stay on the same terminal. If you want to change the virtual memory, this terminal, then you want to open a new terminal, then all configuration will be gone, okay? For this new terminal. You understand what I mean. So let's change our virtual memory size with -s -v. I will give here some number, but it should be integral of the page size, I think, but I don't care right now. I just give, for example, like this, 20,000 kilobytes. We can check again. Yes, the virtual memory is changed, sizes change. So right now I will run again our binary. Yeah, it will simply give a bad alloc error. It's just throw an error, right? So let's change a little bit more to see the effect. Let's put here one more 100,000 kilobytes. It's not unlimited. Yeah, We can change, for example, 5 to see the slow, to see how much we will wait. Yes, we will fill up the whole virtual memory. We can put here yeah. If we remove the try catch, for example, let's compile again and run again. Yeah, as you see, the program is terminated and our texts are not written here. So do not forget to change the virtual memory size for your terminal. There are 5 ways to access the elements, and I am talking about them for 2 of them right now. But there are also 3 of them exist, and you can try yourself. There is a front public memory function. It is used to access the first element. The back is to access the last element, and data is accessing the actually the pointer. It returns the pointer to the first element of this vector. So, for example, we have a 10 an integer. We can access elements of this vector with an brackets, square brackets operator like this, like an array. For example, this one, or we can do that again. This one. We can print it, or we can also access same way like this with an add function. For example, 0 to the first element we can access, or we can change. It gives an error. As you see, it prints the numbers we just assigned. So what is the difference between them? In which case we should use the square brackets, or which case we should use the add function? The thing is here, you can access the elements within a square brackets. For example, we can access to non-existent element. For example, like, I don't know, 200 we can write here. There is no element in this vector as this number, right? But we can access with this square brackets operator. For example, we can just compile, and as you see, it doesn't give any error during compilation, right? Also, we can run. There is no problem. This is a problem, right? This is actually a really problem. So, but when we try with this accessing the non-existent element, I mean the out of the element which is in out of range with an add function, then we can see difference. Yeah, it says that you just try to access the non-existent, and which is in out of the range. So is the only difference between the add and the square brackets actually, and checking the boundaries. With add methods, you can check the boundaries. If you cannot access the element, it's not exist. Okay, this is the point. But square brackets, you can do that. And also, as you see, it gives an out of the range error when you try to access with an add function. As we talked before, we can see the size of the vector with the size method. But there are also capacity method that we have to talk about. Capacity and size are not the same thing actually. When you push the new things to the vector, size is increased according to how many elements you push, but the capacity is increased by a factor 2. And this is not the correct for every time. The vector, as you see, now the right hand side shows the capacity. but the left hand side shows the size. For example, when the size is 1 here, as you see, the capacity also is 1. And size is 2, capacity is 2. But when the size is 3, capacity is 4. What does it mean? When the size is 4, capacity is 4. But size is 5, capacity is 8. So as you see, it increased factor by 2. So what is the point of that? Why we need it? Because pushback has an amortized O1 complexity. That means actually expansion has to be geometrically, but not every time. I can truly say that and capacity will be greater than the size for relatively all cases. You can change this situation with the shrink with size and a clear. You can try with this. You can also make the size and capacity will be equal. It depends on you. But when you push something new to the vector, the capacity is increased not like the size. Size depends on what you push, the number of pushing elements, but the capacity is increased factor by 2. This is the point. This is about the time complexity. So let's play with the vectors. Let's create a vector with some elements like this. 1, 2, 3, 4, 5, 6, 7, 8. As you see, this vector is sorting in an ascending order. Yeah, let's sort this array, for example. When you do it's simply begin and end, it will just try to sort the vector in an ascending order. It's already sorted, right? We can print the vector iterating through using the C++11 range-based loop like this. Let's compile. It gives an error. Sort is not a member of std, right? We should include the algorithm here. I forget. Algorithm library. Let's compile again. Yeah. Vector. As you see, it prints in an ascending order also. It's already sorted. What if you wanted to sort in a descending order? We can use, actually there are a lot of ways to do that. We can use function objects. For example, std greater. Also, you have to declare the size, also in type, I mean. Like this. Compile again. Run again. As you see, it's sorted in a descending order right now. It's a good idea also. Yeah, great. What if I want to use another type? Okay, in the next couple of minutes, I will create our own types, our own class, and I will show you how we can use the new types that we create with the vectors. But for example, with pair, for example, how we can use it? I will create a new vector here with an as a type of the pair. It keeps the pair of elements as an integer and integer. You can change if you want char or other and types. I will give it the name of vec2, and it should be defined like this. We can print the elements with for loop that would be before, like vec2, but this time we have to call the first and the second elements as first and as second, like this. Std end line. Let's put a new line. Let's compile. We have any error? Yeah. So now let's check what we can do. Let's, I don't know, let's sort this vector in an according to the first element, and in a descending order, right? It's already sorted according to the first element as a ascending order. Let's sort it in a descending order. So there are a lot of ways again to do that. We can use greater, but at that time, let's write our function object to sort in a descending order. And I don't know, comparator, let's say, comparator, it's. So you have to implement this function here. Bool, as a bool, it will return just true or false. Comparator, std. It will take as an argument two pair elements. Which is on left hand side. And std, let's say pair is the same. But this will be right hand side. This can be also whatever. It doesn't matter, it's another example. So it's just return if left hand side of the first element is greater than the right hand side of the first element. Just returns true, right? Also, we can print after this. Let's use different way to print with an iterator, for example, in an STL style. Vec iterator, I just give the name. And the for loop, the notation like this. You just assign the vec begin, vec2 begin, the first element. Then it will go through as long as it's not equal to the end of the element, end of the vector. And we will just simply increase by one the iterator. And then we just print out with an as a pointer. We have to use this an arrow to access the elements. First, then vec it, second std end line. So let's try. Yeah. Let's run. Yeah. Before sorting, as you see, it's sorted in an ascending order. After sorting, in a descending order. That's working great. So what we can do, let's check. Also, you can create the type def. This is also a good idea to use the types. For example, we can define the pair int and int like this. Then we can create vectors like this, for example, vec ee. That's like this. Vg, this is not good idea. IE vec, for example. Yeah, this is good. So we can also do this. In here, if you don't want to use or create your own functor, you can use also a greater functor we used before, like this, for example. It will give the same result. The notation will be like this. It will give the same result. Let's try. Yeah, it gives the same result. Also, we can use lambda expressions to sort. For example, vec2 begin. The arguments you should write here. And it's the same in the function declaration. There's a left hand side and a pair int, and this should be the right hand side. This should be also the constant, nothing matter. I just right now here. This also can be a constant because we don't change anything here. It will be a good idea to write here constant. It will be the same, return if the left hand side of the first element is greater than the right hand side of the first element, just return true. And I just forget here the parentheses. I think one parenthesis, and this one is, yeah. Like this. Let's compile. Great. Yeah, this gives the same result. So let's create our own class, our own type. The name, for example, example. This is funny, creative name, right? So I will just create two private member function, member variable, and y, I and y, and also in the constructor I will assign to them is a public constructor example int I, int y, and I will be to I. So we can create and construct this vector with our own type, like this. Just write here your type, that is all. Vec example, for example, vec x, let's write. So it's empty, right? Now let's put something inside manually. We can print them. So when we try to print like this, as you expect, it will give an error. Let's see. Yeah, because we didn't overload the operator. It will here somewhere the beginning. Yeah, this operator is not overloaded. We have to overload this operator to print from the cout, which is a stream insertion operator, as you see. So then here in the public parts, we will overload the stream insertion operator. It should be a friend, because as we know that comparison operators and all the binary operators that not modify their left operands. The overloaded operators method should be friend then. So it will return a stream operator, let's say, like this, std or stream out constant example x. It just simply print, it just returned out I, for example, x I, and also y, x dot y. And also it will return dot. Let's try again. Again, operator, right? Operator. like this. Yeah. Yes. Yeah, it's just print members. Then let's sort it again, what we did before. Actually, before sorting, let's try a different thing. Not sorting like before. Let's remove some elements from this vector. Okay, then we can sort again. For example, we just remove the elements which is greater than the 5. How we can do that? So simply we can use arrays, for example, arrays method. So it will remove until the pointer that you should show. First we have to use the remove if to align, to reorganize the all elements according to our cases, our situation here. Remove if it will begin from the beginning of the vector end, and we use a notation for lambda expressions. It is easy to write. It just get a constant example x, and if it is greater than 5 of the first element we are looking for, then it will return true. Yeah, but here we need a function, public function, which returns the I element, right? Then let's implement here. Integer get I should constant, simply return I. For remove if, there's only one parenthesis more needs, and it will be end to the until end to the, but this will be vec x, right? Not the vec. This also x x, tamam, okay. And this one x. We just simply remove the elements which are greater than 5 according to the first according to the I elements. So let's try. Yes, it will not give an error, but we didn't print anything. Let's print. Yeah, as you see, the elements which are greater than 5, the first element I mean, they are removed. So we can sort this vector in a descending order, for example, according to the element I element. We didn't overload any. Yeah, did we overload something? Right? No, right? Yeah, we just overload the insertion operator, not the comparison operator, right? So it will give an error right now. Yeah, it will give the error about which operator. This operator is needed, as you see. Let's overload it. It's looking for a greater operator, right? As you see, it's interesting, but this also different. The same reason with like the insertion operator. It just take 2 arguments. Example left hand side and example right hand side. So it just return if x, left hand side I is greater than the right hand side I, but it depends. If you change this one like this, then it will sort in an ascending order, right? So there is no actual point. Let's compile again. Right, great. It just sorts in the descending order according to the I. Here actually, as we know that friend functions are non-member functions. I just implement it in the class, an example class, but it doesn't mean it's a member function, right? That is why actually it is a friend also. Yeah, with the operator overloading, that is why it's used, right? We can sort this class, this vector, actually, with our own comparator, our own function objects, our own functors, right, let's say. So let's implement a static method. Okay, first here. Let's implement a static method that will simply compare two example class. Constant example, it will be the same with the operator one. Left hand side, it just return the left hand side of I is greater than the right hand side. Then we can simply access here example comp, for example, like this. It will give the same result. Let's compile, run. Yeah, it will give the same result, right? The vector is sorted according to the first element I. We can, for example, I don't know, we can implement here another class to sort our vector. For example, class comparator class. It can have a public, let's say, I don't know, constructor, or we don't need any constructor, simply a boolean function operator. We just overload like this. Constant example, it will just again take in two arguments, which is on right hand side, actually left hand side. Constant example right hand side, just return if left hand side of I is greater than the right hand side of I, then true, just return. So to try that, we just write here example comp like this, and we have to give this parentheses like this. Yeah, no error, but it gives the same result. Good. So what we can do now, we can try, for example, this sorting process with our own functor, which is written by in a way of lambda expressions, right? Let's do it like this. For example, let's create an auto sort x. Let's write here our lambda expressions. Okay, that's just pass this sort x to this sorting method, right? It just again take them two arguments. Example left hand side, constant example right hand side. Just return again example, left hand side is I is greater than the right hand side, then it will just return true. Just can write again here sort back x begin back x and simply now we can pass like this. This is also a good notation that you can use. I really like it. I use it very much. Let's compile again. The wrong command. Let's compile and run. Yeah, it gives the same result then. Great. Let's check what we can do more. I don't know. We just create a new class type and we create and overload things here. What happens if you want to sort, for example, with nothing? I mean, for example, we use this function objects, we use lambda expressions, right? But what if I want to simply sort vec x begin, vec x end, for example? It will ask you to overload the operator for the comparison, but let's see. Yeah, which operator, which is smaller one, right? Which is this one. So to sort this in an ascending order, or it's already sorted in an ascending order actually. You can also overload this operator. It should not be friends because it is only take one argument. Then you don't have to declare as an, you don't have to define as a friend operator. Just take constant example x and it will return x I is greater than, or that's I is greater than x I. It can access the private because we are inside the class, right? So let's put it in a constant also. We don't change anything. Also this is not a constant. This can be also constant, but whatever. We can run again. But it doesn't mean anything because it's already sorted in an ascending order. So we can change here the direction of the comparison, for example, right? Well, we didn't print anything, right? Let's print here. Yeah, it gives the same. One here. We are, I think we made a mistake, I think here. I want to change the direction. Why gives me the same result? This is not logical. Then I put here, let's try again. Oh yeah, I made a mistake. As you see, it is in an ascending order. I just changed the direction of the sorting. I can also sort like this, but it's not a good way. So, for me, that's all for the examples. I can create again in the next more examples about the vectors, more advanced usage about the vectors also. Thank you, bye. So let's check this example. This question is asked in the interviews actually. Let's check. For example, we have a vector, 10 elements, right? We just implemented, and we want to print the size and the capacity here, and the vector of size of. This one is 10, right? This one is 10, right? We don't push anything. So what will be the output of this? As we know that size of, it just returns the type of the size, right? So here the type is an the vector. So to answer this question, we have to check the definition, the header file of this vector, right? As you see that, if you check this header file, you will see a lot of functions and members and variables. As we know that this struct, this class, even if in class or struct, a size of depends on the variables, not the functions. So if you see that there are 3 pointers, so it will return this size of these pointers, right? Not related with this size and a capacity. So be careful about it. As you see, there are 3 pointer there. First one is start, finish, and end of the storage. It depends also the your machine. If you use 32-bit machine, the pointer size will be 4 bytes. But if you use 64-bit machines, then the pointer size will be 8 bytes, right? So in case of mine, it will return 24. It will return 24 because there are 3 pointers, and I am in the 64-bit machine. One of them is an 8. 3 times 8 is 24. Now what if, and I will change the size, my virtual memory, really small value like this. What if? Segmentation fault. And 10, for example. Lips so fail. Even if not enough memory to call the dependencies, shared libraries. It's funny. Interesting.